Okay, dear friends, we shall now revise triangles, chapter triangle of 10th maths. So here we shall see what are things we need to know in this. So here, first of all, we should know what is similar figures. Similar figures are those if they have the same size and same shape but different size are called as similar figures. And similarly similar polygons. So here also the corresponding side angles are, if they are equal and corresponding sides are in proportion, then they are also called as similar polygons. So here, for example, there are two quadrilaterals. You can see the corresponding side, corresponding angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R, and angle D equal to angle S. If the corresponding angles are equal but the corresponding sides are having the same ratio, like here you can see AB by PQ is equal to BC by QR, and that is also equal to this ratio is also equal to DC by RS, and similarly DA by SP. So all their ratios are the corresponding sides ratio is same and corresponding angles are equal. So such polygon is called as a similar polygon. Then we also need to know here in this chapter what is the difference between congruent triangle and similar triangle. In congruent triangle, they have the two triangles are having the same shape and same size. So here, for example, triangle ABC is congruent to triangle PQR. So how we can say that they are congruent? So if angle A is corresponding angle are equal, angle A equal to angle P, angle B equal to angle Q, angle C equal to angle R, and also the corresponding sides, if their ratio is if corresponding sides are equal, if the corresponding sides are equal, like for example BC is equal to QR and AC is equal to PR and AB equal to PQ, then these two triangles are said to be congruent, and their corresponding sides the ratio is equal to 1. So such triangles, so here triangle ABC is said to be congruent to triangle PQR. This congruency is represented by this symbol equal sign or tilde symbol. Then similar triangles. What is similar triangle? They have the same shape but not the same size. So here given triangle ABC is similar to triangle PQR if corresponding angles are equal, angle A equal to angle P, angle B equal to angle Q, and angle C equal to angle R. But the corresponding sides are not equal, but their ratios are equal. Like BC by QR is equal to AC by PR, that is also equal to AB by PQ. If the ratio of the corresponding sides are same and corresponding angles are equal, then such two triangles are said to be similar triangles. So triangle ABC is similar to triangle PQR, and that similarity is represented by the symbol tilde. So then similar triangles, how you can define these similar triangles? The triangles, if the two triangles are said to be similar, if their corresponding angles are equal and corresponding sides are in proportion. And here all the congruent figures are similar, but converse is not true. So that is all these things we need to know in this. Then what is basic proportionality theorem? Thales theorem. So here I have a triangle ABC. If I draw a line DE parallel to BC, then it divides this D divides the two sides in the same proportion. So that is of the other two sides. That is, if D is parallel to BC, AD by DB is equal to AE by EC. So what the basic proportionality theorem says? If a line is parallel to side of a triangle which intersects the other two sides in distinct points, then the other two sides are divided in the same ratio. Then what is the converse of BPT? Suppose if a line divides the two sides in same proportion, that is AD by DB is equal to AE by EC, then we can say that D is parallel to BC. So that is the converse of BPT. Then Pythagoras theorem, which we are already familiar. In a right angle triangle, so here given triangle XYZ, where angle Y is equal to 90 degree and XZ is hypotenuse. So if angle Y is equal to 90 degree, then XZ square, the square of the hypotenuse, is equal to sum of the squares of the other two sides, that is xz square equal to xy square plus yz square. So this is the Pythagoras theorem. Then converse of Pythagoras theorem, if in a triangle square of one side is equal to the sum of the squares of the other two sides, then the angle opposite to the first side is equal to 90 degree. If xz square is equal to xy square plus yz square, then the angle opposite to xz is angle y, which is equal to 90 degree. That is the converse of Pythagoras theorem. Then here if a perpendicular drawn, here we have a triangle ABC where angle B is equal to 90 degree. If a line is drawn, perpendicular is drawn from the vertex of the right angle, that is angle B, to the hypotenuse, so then we can say that here the two triangles are formed. These two triangles are similar to each other and they are also similar to the main triangle, that is angle ABC. So how you can see here, triangle ADB is similar to triangle ABC, and triangle BDC is also similar to triangle ABC, and triangle ADB is also similar to triangle BDC. So what it says here in this theorem, if a perpendicular line is drawn from the vertex of the right angle to the hypotenuse here, then we can see that there are two triangles are formed in this triangle, which are in this case the two triangles are similar to each other and they are also similar to the, each triangle is similar to the main triangle, that is ABC here in this. So then areas of similar triangles. So if I have two triangles ABC and PQR which are similar, then the ratio of the areas of two triangles is equal to the square of the ratio of the corresponding sides. So that means here area of a triangle ABC divided by area of a triangle PQR is equal to AB square divided by PQ square, and that is equal to AC square divided by PR square, and that is also equal to BC square by QR square. So that is the areas of a similar triangle. So in the problem you will be given any of these and you are asked to find the other one. So then what are the criteria for similarity of the triangles? If in the given two triangles, if all the corresponding angles are equal, all the three corresponding angles are equal, that is called as a AAA similarity, then also we can say that those two given triangles are similar to each other. Then if corresponding two angles are also equal, then also we can say both the triangles are similar. Of course both are one and the same, because you know that total sum of the angles should be equal to 180 degrees. So either if two angles are matching, then we can say the third also will definitely be equal. Then SSS similarity, if in the given two triangles corresponding sides are equal, corresponding three sides are equal to each other, then also we can say that those two given triangles are similar to each other. Then last similarity condition is, suppose if in the given triangle two sides and one angle, if two sides and one angle are corresponding sides and corresponding two sides and corresponding one angle is equal, then we can say that the two triangles are similar to each other. So that is called as SAS similarity. So these are all the things that we need to know in this chapter triangles, and with the help of this definitely you will be able to solve the given exercise problems, and I hope it will definitely help you in a last moment revision of this chapter triangles. Thank you. Please subscribe.